Okay, so we're going to use tables to approximate the solution to a system of equations. The system I have here is y equals 5x minus 1 and y equals negative 2x plus 11. And I have a table of values here. And remember, when we're looking for the solution to a system, we're looking for the outputs, the y values are equal. And so if you're looking here, we don't have any that are actually equal right now. Negative 11 and 15, negative 8.5, 14, right? None of these are matching up. So we're going to approximate the solution by looking for the ones that are closest. And you can kind of see here that these are 5 apart, these are 1.5 apart, these are 2 apart, these are 5.5 apart. And this is where they are the closest, between 1.5 and 2. So that's telling us that our solution's got to be somewhere between these guys right here. Okay, another way to look at it is that these values are increasing as we move down versus these values are decreasing as we move down. And right here, 6.5 is lower than 8. But right here, 7 is lower than 9. So again, the answer is going to be somewhere between x is 1.5 and 2, and somewhere between y is 6.5 and 7. Okay? And so to kind of zoom in on this table and see exactly where that value would be, let's go to the next one here. Okay, so I've zoomed in on my table. I've copied over that 6.5 and 8 value. I've copied over that 9 and 7 value, and we're going to evaluate our function at some other values along the way. So like 1.6, I'm just going to be substituting the value I need in for the x each time. 5 times 1.6 minus 1 tells me that this is going to be a 7. And then 5 times 1.7 minus 1 tells me that this is going to be a 7.5. And you can kind of keep going in that same pattern. 5 times 1.8 minus 1, 5 times 1.9 minus 1, to keep getting the values that would go in the first column. We're going to evaluate our function at those values on the second one. Negative 2 times 1.6 minus 1 gives me a, oh, sorry, that's plus 11. My bad. Negative 2 times 1.6 plus 11 gives me a 7.8. We will evaluate at 1.7. Negative 2 times 1.7 plus 11 gives me a 7.6. I won't keep writing them, but we're going to kind of do the same thing. Substitute in a 1.8, substitute in a 1.9. And again, we're looking to get these values as close as we can get, right? And this is as close as we are getting right here, which tells us that we can approximate the solution somewhere around 1.7 for our x value. And I'll just say 7.55 for the y value, because it's going to be between those values. It's as close as we're going to get. We could zoom in even further and do like 1.7, 1.71, 1.72, but we're just trying to approximate at the nearest tenth, and that is where we're at right now.